All right, so our first topic that we are talking about with linear functions is just identifying what a function is. So I'm going to briefly go over what you learned in the video yesterday and what you practiced yesterday, and then show you how we figure out if a graph is representing a function. So yesterday we just talked about is a relation a function, and we looked mostly at input output tables. So in the table, a table is showing a relation, and a relation is just something that pairs one set of values, the input, with another set of values, the output. So if we have a table like this one here, we have the input and the output being represented here as the input and in this column as the output. So one example could be the number of miles run and the time that it takes in minutes. So the input is the miles that are run, and the output is the time. So let's say in this set, it says when you run 4 miles, it took 36 minutes. The next day you go out, you run 7 miles, it took 70 minutes. The next day you run 5 miles and it took you 42 minutes. And then the next day after that, you run 5 miles again, but this time it takes 45 minutes. Okay, so that's one example of a relation. A relation is anything that has an input and an output. This next table is a different example of a relation. So this time it's relating the age of a puppy, which is the input in months, to its weight in pounds, which is the output. So this would be representing one particular dog or puppy. So at 1 month, the puppy weighed 5 pounds. At 2 months, the puppy weighed 12 pounds. After 3 months, 20 pounds. And after 5 months, 30 pounds. So that's another relation. It relates the age of the dog in months to its weight in pounds. But we're talking in this unit specifically about functions. So not every relation is a function. It's only considered a function if it pairs each input with exactly one output. So let's go back and look at these two examples and decide whether or not the relation would be a function. So in this first one, first run is 4 miles, takes 36 minutes, 7 miles takes 70 minutes, 5 miles takes 42 minutes, but then the next day, you run 5 miles again and it takes 45 minutes. So these here are the same input, 5 and 5. Even though it's listed twice, that's still the same input. You're inputting the same thing, 5 miles. You're putting in 5 miles. But you're getting a different output. The first time you take 42 minutes, the second time you take 45 minutes. So this relation is not a function. The number of miles run and time in minutes, that relation is not a function. Okay, let's look at the other one. We have 1 month, 5 pounds, 2 months, 12 pounds, 3 months, 20 pounds, 5 months, 30 pounds. Each input does have its own output, and it has only one output. So if you think about it, let's say that this measurement is always taken on the last day of the month. You could never have two different outputs for on the same day, right? If at the end of 5 months, the puppy weighs 30 pounds, that's always going to be the output that goes with 5. right? So this one is a function. The weight of the function, or the weight of the puppy, is a function of its age. Okay, so review of what we did yesterday. Now, moving on to our new question, or our new skill, is determining whether a graph is showing a function. So we haven't looked at any graphs yet this year. So what I'm going to do is I want to use the same examples that we already used, so we can apply what we know about that to what it would look like on a graph. So let's just review. This first one was not a function because 5 miles had two different outputs. And this one was a function. Okay, now anything that has an input and an output, I can put on a graph. So the input is always going to be on the x-axis, and the output is going to be on the y-axis. So this time on the x-axis, or the horizontal part of the graph, we're measuring miles run, and on the y-axis, or the vertical line on the graph, we're measuring the time that it took. So each of these sets that go together can be marked as points on the graph. So to graph the first point, I'm going to start right here at the axis, and then I go over 4 because we ran 4 miles, and then I am going to go up to 36, which I'm going to have to estimate is about right there between 30 and 40. Now, I'm going to erase that line because we don't actually want that line there. I was just showing you how I was getting to that point. Okay, cool. Next point would be when they ran 7 miles. It took 70 minutes. That's going to be this point right here. All right, the next point, they ran 5 miles and it took 42 minutes. But then we have another point. We have when they ran 5 miles, it took 45 minutes. So that's the same thing, 5 miles, 45 minutes. Okay, now something that stands out to me right away is that these 2 points right here both have the same input. They both have an input of 5. We went over 5 and we went up 42, and then we went over 5 and we went up 45. Okay, and I know that this one is not a function. So this graph represents something that's not a function. We're going to look at the graph of something that would be a function and then compare and contrast to see, to make some general rules that we can follow. Okay, so when I'm graphing, the next one I'm going to do the same thing. My input is on my x-axis and my output is on my y-axis. So for the first entry, I have the puppy is 1 month old and weighs 5 pounds. Then 2 months weighs 12 pounds. 3 months weighs 20 pounds. And then 5 months weighs 30 pounds. Okay, so this is a graph of something that is a function. Now, we already knew whether or not these were functions because we had looked at the tables to start with, and the tables told us whether or not it was a function. But you can determine if a graph is a function without having to have a table with it, just by looking at the graph. And to do that, we use something called the vertical line test. So the vertical line test, and you're going to want to copy this down into your notes somewhere, but the vertical line test says that if a vertical line touches any 2 points at the same time, it fails the vertical line test and is not a function. So if we look at the first graph, let's say we put a vertical line here. Vertical line is one that goes up and down. It only touches 1 point on the graph. So that one's fine. But what if I put a vertical line right here? That would fail the vertical line test because this one is on the vertical line and this one is on the vertical line. And that can't happen according to the vertical line test. So you have to be able to put a vertical line anywhere on the graph and it never touches 2 points at the same time. If we tried it with this one down here, this passes the vertical line test. These all pass the vertical line test. No matter where you put the vertical line, it's never going to pass through more than 1 point at a time. So the rule that we want to follow is if a vertical line touches any 2 points at the same time, the graph fails the vertical line test and is not a function.